Okay, so this continues a series of videos where I'm looking at functions and then the derivative of those functions. And then one of the things that is brought up in the chapter is sort of relating these things to the real world. So here I've got a graph here, and this is 5-year average inflation rates from 1918 to 2009. And I went online and I got data from the inflation rates, and unfortunately I didn't write down my source, so I apologize for that. And I found the inflation rates, and then they were kind of all over the place, so I averaged them out. So each year is the 5-year average of the 2 years previous to the 2 years after. So a little 5-year window there to smooth things out a little bit. And so this is the inflation rate, is how fast the prices are going up. So back here, the prices were going up really, really fast. In this region, the prices are continuing to go up, but they're not going up as fast. At this point in time, the prices are steady, and then the prices start to drop. And here the prices are still dropping, but not as severely. Here the prices kind of level out for a little bit, and then as we get into the Great Depression, prices drop and they drop and they drop and they drop. They're still dropping, but they're not dropping as fast as they used to. And then as we're coming out of the Great Depression, prices start to hold steady, and then they start to increase. As we go into a war, the prices of things gets more and more and more and more and more and more. After the war, the price of things continues to increase, but it increases at a slower rate. All through sort of the 50s and 60s, prices were going up, but they were going up slowly. As we moved through the 70s, as we moved through the late 60s and the 70s, prices start to go up more and more and more severely. So then prices were going up really, really a lot per year, 10% per year in 1980. Then prices continue to go up, but they're not going up as fast. And then here through the sort of the late 80s through the 2000s, prices have been going up, but they've been going up at a fairly steady rate. Okay, so that's kind of akin to what I did in my previous video of using a slope graph, f prime of x, so this is going to be like f prime of x, to generate a graph of f of x. And so I'm going to sort of do that, and I'm also going to do it the other way, start with an f of x graph and go to an f prime of x graph. And I'm going to do that with two different things. Okay, so to start off with, I went and www.foodtimeline.org, foodfact5.html. Somewhere in there, somebody had done research and found the price of a pound of Oreos. I actually sort of made these for a pound. They're all different sort of values of weight. So I made it so basically based off of their research of looking at advertisements, how much a pound of Oreos cost in each one of these segments. And so this is an f of x graph, where this is the price of a pound of Oreos. And so then what I'm going to do is I'm going to convert this into basically an inflation graph. And so here I'm going to say we're going to have our graph. And this is going to be the inflation of Oreos, and this is going to be percent increase in price, and this is going to be year. Okay, so let's probably make that, we're probably not going to have, what's our biggest increase in price going to be? Probably 1.83, so that's 0.4. 0.4, that's not the one that I want. I want this calculator. So if I go 0.4 divided by 1.43, probably talking about 30%. So let's call this 0.1, 0.2, 0.3. Well, that should be 10%, 20%, 30%, negative 10%, negative 20%, negative 30%. And then we've got 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, 85. Okay, so what I'm going to do is I'm going to do, let's see where I can get it. There you can see it. So I'm going to do 0.83 minus 0.95 divided by 0.95. Negative 13%. So my graph, so from here, that's got a slope of negative 13%. So coming back here for 75, 76, I'm going to put it right about there. Yep, that's what I'm happy with. Okay, and then I'm going to do another one demonstrating here, and then I'm going to go kind of fast. So now we go 0.95 minus 0.83. I'm sorry, 0.83 minus no, it's first one minus that one. So this one minus that one divided by that one. Gotta type correctly. And that's like 0.14, 0.15. So probably right about there. Okay, so then I'm going to go through these really quickly. Just bear with me. Negative 0.13 again. And then 1.12, that's a big jump. That's 33.33%. And I'm going to just do two more here. Negative 0.5%. And then last one. about 34%. That should be up there. And that should be up there. Okay, so then if I look, I've got this crazy kind of graph of the percent inflation of Oreos. And so that's kind of the slope. That represents the slope of this line. So my slope is negative, then it's positive, then it's negative, then it's positive, then it's negative, then it's positive. And it's kind of like shallow, 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 steep, shallow, steep. So I've got kind of shallow, 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 steep, shallow, steep. And what you'll see if I did the whole thing out all the way through, you would see that this graph spends more time above the x-axis than it spends below the x-axis. So that means that it's spending more, the price of Oreos is spending more time going up than it's spending going down. So even though the price of Oreos is going down basically every other year, overall the price of Oreos is going up. Okay, there's that video. In the next video, we're going to go back the other way, and we're going to take yearly inflation rates and convert that into a graph of dollars. Okay.